The largest flying creature defied physics. How did it launch? A Quetzalcoatlus was immense, dwarfing modern birds completely. Though its wingspan approached the length of a small airplane, maintaining such a large structure required specialized bone density. Its bones were hollow, reinforced tubes, incredibly light yet strong. But this leads us to the first major challenge, takeoff mechanics. Unlike birds, it could not simply jump into the air. A method wanted the quadrupedal launch, using all four limbs to push. It drove upward, achieving momentary ground clearance with brute strength. But this required immense muscle mass concentrated in the chest area. However, its sternum anchored massive muscles, disproportionately large for its weight. And now that we understand the immense power needed, let's explore method 2. Method 2, the running takeoff, utilizing horizontal velocity. This method minimizes the vertical struggle against gravity immediately. The wings are held partially extended, catching the ground effect lift. At the precise moment of speed threshold, the upstroke begins. This required perfect timing between leg drive and initial wing power. The ability to run effectively made launch much more viable. Method 3 addresses the persistent issue of high wing loading. Reducing drag was crucial for these immense airborne structures. The head tuck minimized the frontal cross-sectional area exposed to airflow. This aerodynamic shaping saved precious energy during sustained cruising. Imagine the energy savings across thousands of kilometers traveled yearly. Method 4 involves how they controlled those vast, thin-wing surfaces. They likely possessed sophisticated passive stability mechanisms. The wingtips could warp slightly to manage turbulence and sharp turns. But this fine control prevented catastrophic stalls at lower speeds. Now that we understand maneuvering, let's explore the final, crucial method. Method 5, mastering the invisible highways of the atmosphere. But these giant reptiles were expert thermal soaring specialists. But they would circle tighter and tighter, maximizing vertical lift acquisition. But this transforms solar energy, absorbed by the ground, into kinetic energy. And imagine dozens of these giants utilizing the same atmospheric currents together. The skin itself may have played a role in heat absorption, aiding lift. But how did they survive the transition back to the ground? Its head, though large, needed to remain elevated for spotting food. But when rested, the wings folded tightly against the body for protection. The creature adopted a quadrupedal resting stance, similar to its launch preparation. Its beak was adapted for tearing, suggesting a scavenging or opportunistic diet. Its terrestrial movement was necessarily slow and deliberate due to limb structure. But the sheer scale means a failed launch attempt carried significant consequences. The key takeaway is the fusion of power and optimization in its anatomy. But no modern analog exists. This was an evolutionary extreme. The shoulder joint had to withstand massive torque during the downstroke. Smaller relatives achieved flight much more easily through simple flapping. The larger the animal, the more critical these specialized techniques become. A wind shear presented a constant threat to its massive, flexible wings. Its vision needed to be exceptional to spot prey from such heights. A vision integrated perfectly with its flight planning and hunting strategy. The combined 5 methods created a viable niche for giants above the clouds. The tail acted as a critical stabilizing rudder for directional changes. It navigated the three-dimensional world with surprising, brute force grace. Understanding these mechanics illuminates the limits of terrestrial evolution. Every component, from bone to beak, was optimized for this extreme lifestyle. And the necessity of flight drove radical, specialized anatomical restructuring. But even mastery requires an end to the soaring day. The landing was a controlled crash, absorbing tremendous momentum. Its success was a testament to biomechanical limits being pushed past comprehension. 5 distinct strategies allowed this titan to conquer the atmosphere. But these ancient flyers remain the benchmark for airborne giants.